Hello, geometers. Welcome to the lesson on proving some properties of a rectangle. So we're going to look at theorem 8.13 here. A parallelogram is a rectangle if and only if its diagonals are congruent. And all this stuff here was from a prior proof, so let's go down here. Okay. So let's draw ourselves a rectangle. We need some 90 degrees here. So we have this rectangle here. Clean this picture up a little bit. And we know that a rectangle has all 90 degrees. Everything here must be 90 degrees. So let's call this A, B, C, D. Okay. Now, what we want to show is that the diagonals are congruent. So from A to C and from B to D. Okay. So our task here is to show that AC is in fact congruent to DB. Okay. And the strategy, as we've always done before with these particular parallelograms and quadrilaterals, is try to split them into triangles. So that's exactly what I'm going to do. I'm going to just take out this triangle here, this blue one. Okay. I didn't draw it very well here, but B, C, D. And then I'm going to take out the other triangle, the red one here, with a bit of overlap. And when I say take out, I'm just drawing them separately so that you can see a little bit more clearly. Right. Okay, and let's see what they have in common. Well, first they have 90-degree angles here. So that's really, really nice for us. So we can say a few nice things about this. And we're going to show that this is true using CPCTC. Okay. So prove that these two triangles are congruent, therefore AC and BC, DB must also be the same. So let's see. First, you can see that the sides AD and BC must be the same. So I can mark this here. So AD is congruent to BC because they are opposite sides of a parallelogram. We've proven that before. If something is a parallelogram, then the opposite sides are congruent. We see that each of them has a 90-degree angles. So angle ADC is congruent to angle BCD because they are both 90 degrees. And finally, very simply, if you look at this side length here, DC, it's the same side length for both triangles. DC and DC are the same. So DC is congruent to CD because it is reflexive. Okay. Therefore, the two triangles here must be the same. Triangle ADC is congruent to triangle BCD by side angle side. And since you have congruence between the two triangles, the remaining side lengths must also be the same. So 5AC must be congruent to DB by CPCTC. And there you have it. That completes the proof. Now, this is not the only way to do this. You can certainly also prove this using the Pythagorean theorem. If you notice that the legs here are the same of a right triangle, so therefore the hypotenuse, the hypotenuses or the hypotenusae must also be the same. As always, keep working hard on these problems. If you have questions, ask your teacher. Thank you for watching, and have a wonderful day.